Okay, so for your infinite series, if this was a ball bouncing, and conveniently I've left off the first drop because that doesn't get doubled. Okay, so I'm trying to keep life a little bit simpler and say, okay, from there on it doubles everything. This ball bounces up to, let's say, 4 feet, and then it bounces up to 2 feet, and then it bounces up to 1 foot. And I'm just, if I make a little list like this, it's a lot easier. Then, what's that formula again? A over what? You have a short-term memory or not? 1 minus R. Good. A over 1 minus R. Got to have that one down. And then what is A? A little more participation would be good. What is A? 4, okay. And then 1 minus R, what is R? 1/2. And hold on just a moment, please. Pausing the video. Okay, so we have 4 over a half, and that makes what? 4 divided by half to 4 times 2. What is 4 times 2? 8. There you go. That should have added up to 8. Now, where's that whole doubling thing? Well, that wasn't doubling. That was just adding 4 plus 2 plus 1. And if I needed to double it, I would double it and say it was 16. Why would I double it? Because, again, a ball is bouncing, it's traveling both directions, up and down. Right? All right, so 8 is the answer to this simple sequence. In the real world, of course, life gets more complicated. It didn't just travel 4 feet and then 2 feet. It went up 4 and back down 4. It went up 2 and back down 2, etc. Now, this one assumes that its first bounce was at 4 feet, which would imply what was the drop in the very beginning. If the first bounce went up to 4 feet, what did it start at in the first place? It must have started at 8 feet. Okay? And that's not included in this list. Why? Because it doesn't get doubled. When you drop that first drop, it doesn't get doubled. All right, so if you wanted to complete the bouncy ball lab, that's pretty much how you would have done it, is you would have said, okay, cut out the first drop, and after that, everything just gets doubled. Now, again, are we doing the bouncy ball lab? No. I'm letting you out of the bouncy ball lab in my class this year because I'm going to have a sub when I come back, and I can't have a sub try to teach you a lab and stuff. That would be a nightmare for everybody. So we are going to, I just talked you through the bouncy ball lab, and this total distance it traveled, which is 8, you have to be able to do that. Let's do another one that's kind of weirder. It's going to flip-flop back and forth. Let's say I start with 6, and then I use an R of -1/3. Would you please list out, let's do the first 4 terms this time. List out the first 4 terms of this. And then if this qualifies to use that formula you just learned, the geometric formula, then use it and figure out the answer. Figure out what this adds up to. Hint, your first one is multiplied by -1/3, and you get -2. Right. And then the next one's going to be positive because you're multiplying by -1/3. I don't need you to get decimals for this. You don't need a calculator for this. You can just get fractions. It's okay. Your formula, I get at the end, you're going to have some fractions. You should be able to take 1 minus a fraction. That's not that bad. You should be able to handle that. So I think, honestly, your life's a lot easier if you just keep this in fractions. All right, I'm going to pause for a minute while you work that one out. Okay, so I'm going to multiply a negative times a negative, makes it positive. 2 times 1/3 makes it 2/3. And then I'm going to multiply by -1/3. That makes it negative again. And that's going to be 2/3 times 1/3 makes 2/9. Those are the first 4 terms. You with me on that? Do you know the right formula that would tell me the 10th term without having to just actually do all 10 terms? Do you remember the formula? If you remember it, write it down. What is that formula for finding the 10th term? A sub n equals... Now's a moment where, for some of you that have good memories, you probably going to be ticked about this, but there is going to be a formula sheet for the test. So those of you that got this, you got these memorized, it's still better because you know how to use them better than some kid who just sees A over B, X to the N. I mean, they won't necessarily be as good at it as the people who have it memorized. Same thing on the ACT. Well, actually, no, not the same thing on the ACT. Same thing on the PSAT. The PSAT gives you a formula sheet. Those that kind of know them in their head and can do them, they're going to be much faster than the kid who actually has to look it up on the formula sheet. So, all right. So what is this formula again? For a geometric, it has an R in it. Does this ring a bell? And then you go A times R to the n minus 1. Sound familiar? All right. Then, I hope you knew what to stick in. If we want the 10th term, then n is 10. A sub 10 would be A, which is our starting number of 6, times R, which was, we knew R. R was negative 1/3. To the n minus 1, well, that's 10 minus 1, so that's 9. And there you go. That's your 10th term. Okay, any questions about that? Then let's talk about the new stuff. It's called binomial expansion. Would you agree that that is a binomial? Do you remember what binomial means? Bi means 2. It's got 2 terms. And if I say a binomial expansion, this would be like the simplest one of them all, and you've been doing them for a long time. It expands it out, right, to x plus 3 times x plus 3, and it actually ends up with 4 terms. Right? Do it. Figure out what the answer is. I personally like to FOIL it first, outside, inside, and lasts. But some of you guys probably like a different method, but it gives you the same results. Let me just show you what I mean. X times x, x squared. X times 3, 3x. 3 times x, 3x. 3 times 3, 9. I'm still doing all the same parts. It's just different order. Some of you are like, whoa, that works? Yep, that works. Okay. Now, we all would, I hope, agree that it's x squared plus 6x plus 9. That is a binomial that has been expanded. It's just you didn't have any fancy way of doing it. You're going to have a fancy way of doing it in a minute. Do you get that if I squared this, it'd be a little more complicated? What's complicating it a bit? What number in there is messing it up? The 3. Okay. The 3 is going to mess it up a bit. All right. So would you agree that this would make it significantly harder? Why? Because now really what you'd have to do is x plus 3y times x plus 3y times x plus 3y. That is binomial expansion. It's just particularly incredibly awful to have to multiply that all out to do it. There's a faster way. But to understand that faster way, I think you need to understand this. So I want you to actually multiply this all the way out. Hint, I would start with this, and then you'll have a trinomial. And then don't forget, if you have a trinomial, that is not the right answer, but let's say you had a trinomial, then don't forget, it's this times this times that, and then this times this times that, and then this times this, and this times that, and they all get added together. Yep, you're expected to be able to handle that much algebra. But when we give you one on the test, this might be a 6. You see how you're not going to want to do it this way anymore once it's a 6? You'd have to have 6 of them in parentheses, all multiplied out. Holy smokes. That would be insane. So there's an app for that. There's a formula for that. There's a way to figure these out with a formula. But I need you to appreciate what's really happening by actually multiplying this all the way out. Don't forget, once you're done, you're going to get a triple times a double, and I just showed you how to do that. Everything gets multiplied by everything. Okay, that's going to take you a couple minutes. I'm going to pause for a minute. I'm going to multiply this puppy all the way out. I'd like you to have a partner, too. I'm going to partner you up right now. So to multiply this thing out, first we would FOIL this out. Then we take each of those terms and multiply it by this. So and then you get a final answer. And I'd like to see Dice of Destiny here. Who should I ask? It's row 5. Person 3. That's you. C. K. What'd you get? Mr. Krabby. Did I say? Did I count it wrong? No, I counted it right. Okay. X to the third. First of all, did you check with your partner? Did you or not? Okay, confer with your partner right now. I'm going to pause for a moment while you work on it. Hit me. X to the third plus 6x squared y. Okay. 9xy squared. Keep going. Keep going. Was just the y squared in that one? Okay. That it? Hoping you eventually finish up here. Okay, keep going. Is that it? That is it? All right. Can anybody verify that answer? You got the same thing. Okay, so then there's some concerns about your answer. Let's look and see if there's any that can be combined. Ah, if those are the same term, then you could put them together, right? Okay. So should that make 9x squared y? Okay. And that 15 should be an 18? Okay. Did anybody get an 18x y squared? A bunch of people did, okay. Yeah, we are going to put these together. Oh, and you think this one's wrong too? No, but that one should go as 8. Okay, so why don't you guys tell me what you think the final answer is? X to the third plus, and then these two you want together, and that makes 9x squared y plus 27 xy squared. And that's because this and this go together. Okay. And then what? All right. Now, I want you to notice a pattern here. The reason we did this. Look at your x terms. What do you notice about them? If I circle them all, I hope it becomes obvious. And wait, there isn't even an x term in that one. Couldn't you say it's sort of like x to the 0 over there? It went x to the third, x to the second, x to the first, and x to the 0. How about the y's? Couldn't you kind of argue there's a y to the 0 here? Yeah, because that's like 1. Okay, and then y to the 1, y to the 2, y to the 3. Seem like a pattern we could go with for our binomial theorem, the way to do this without having to multiply all that out. Okay. And how about these numbers? The number in front, that's a 1, and that was a 9, and then it was a 27, and then it was a 27. Those are some of the tougher numbers to get. Okay, now they have to do with that 3. Do you get a 3 and a 9 and 27 kind of all are based on that 3. All right. So here is another example. Let's just do a simpler one. X plus, let's say y, to the third. Now, that's similar, but it's a lot simpler because we didn't have that 6 to deal with. And I'm going to show you how you would do it with the binomial theorem. Let's pause for a second. All right, as a part of this formula that we do, you're going to be asked to do these. And I don't think that you have seen that in such a long time that you may not even know that that means 3 choose 0. And do you remember what that is? It's combinations, and remember what the P stood for? Combinations, and the P's were permutations. Do you remember doing that in higher algebra? I know you did. Let's pause for a second. Okay. So we're going to need to know how to do permutations and combinations. Actually, honestly, we don't need permutations. We just need combinations. So let's go back, blast from the past. Let's say we had 3 choose 1. All right. Now, that can be done by hand, but I'm not going to expect you to do that by hand. Let's just grab your calculator. Everybody grab your graphing calculator. 3 choose 1. You're going to put 3 in first. Then you're going to go into Math button and PRB for probability. Let me see if I can pull that up on my computer. Okay, so let's watch me put it in the calculator now. I'm going to put in 3, and then I'm going to go to Math, and I'm going to arrow over to probability. On some of the older operating systems, it's just called PRB for probability. Okay, and then do you see it there? That'd be permutations. That one's combinations. Okay, 3 choose, and then I put in a 1. Now again, if yours doesn't shrink it down to subscripts, that's just the older operating system. Don't worry about it. You hit enter, and you get 3. I want to remind you what that means just for a second. Let's say that there are 3 kids, Bob, Lisa, and Sam, and I'm going to choose from them sets of 1, and the question is, how many sets can I pick? It's pretty easy. I can know if I'm only taking sets of 1, I can get 3 different sets, right? So 3 choose 1 is 3. If you want to memorize that one, what do you think 8 choose 1 would be? 8, okay? How about this one? Because this is going to come up. What does 3 choose 0 mean? If I have 3 people and I'm going to choose sets of 0 of them, how many ways can I do that? That's a weird question, but it defaults to a fairly simple answer. There's only one way to do that. You just don't choose anybody. Okay, so that answer is always going to be 1. If you want, just type it in the calculator, 3 choose 0, and it'll be 1. Okay? All right. How about 3 choose 2? That's where it gets more complicated. Now I got these 3 people, and I'm going to choose sets of 2 of them. Like I could choose Bob and Lisa, and since this is a C, the order doesn't matter. Or I could choose Lisa and Sam. That's 2 different choices. Or I could choose Bob and Sam. Is there any other combos that I haven't chosen yet? I think this answer is 3. Would you please do 3C2 and verify it's actually 3? Was it? Okay, good. All right, so that's how they work. But obviously, do you really want to think that through if it's 8, choose 6? You know what I mean? Holy cow, you're definitely going to want to go to the calculator to get those answers. Okay, so this would have been, it would look like this. 3 choose 2. You may not have ever saw that format before, but that means 3 choose 2. You'd put it in your calculator as a 3C2, and the answer would have been a 3. Okay, now let's go back to this. And if I'm going to do a binomial expansion, it's going to involve these things, and these things turn into just numbers, right? just did a second ago, it turned into 3 or 2 or whatever. Okay, those are these, the numbers that go in front. See what I mean? Those are your coefficients. All right, so now, pausing one more time. Okay, so I guess I wasn't recording there for a minute, but here's a quick review of what we did. We took all our x's and went x to the third, down to x to the second, down to x to the 1, down to x to the 0. We made our y's be going ascending order. Y to the 0, y to the 1, y to the 2, y to the 3. And then these little guys, the coefficients, the numbers in front, were 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3, which came out to 1, 3, 3, and 1. Okay, there, that's a binomial expansion. Do you get that if I put this as a 13, you could make all the terms for it? It would be a pain, but you could do it. See what I mean? Just follow that pattern. All right, now I want to back up for 1 second and see. This was an x to the third. How many terms are there for an x to the third? 1, 2, 3, 4 of them. So if I did do x to the 13th, how many terms would there be? 14. Okay. So if I made this x to the 13th, but I said, all I really want is the second term of it. Do you get how you could do that? You don't have to number it all the way to the right. You know what I mean? If I only needed a second term of it, I would probably make the first term and the second term, but that would be it. I wouldn't actually write x's all the way across my page. I would just start with, let's see if you can do it. Tell me the second term of that. Hint, start with 13 to the 0. I'm going to pause for a minute while you guys figure out the second term. I don't need all of the other ones. Just find this second term here. What would it be? Pause for a minute. We'll give that a try. Okay, hopefully you started like this. X to the 13th, X to the 12th, and then you could have kept going, but we only needed the second term, so probably stop there. Y to the what? 0. Y to the 1. And then these just go 13, choose 0, 13, choose 1, and then I could probably do 13, choose 1 in my head, right? If I have 13 different people in the room, I only pick one at a time. How many combos are there? There would be 13. So you should have said, if you're going to simplify it, that's 13, x to the 12th, y. Okay. What if our original problem had a 2 right there? I want you to just take your best guess at what the second term of this would be. Take your best guess what that second term would be. I'll pause for a minute while you do that. Okay, should have started with 13, choose 0, then 13, choose 1. Okay, that didn't change much. How about the x? That didn't really change. X to the 13, x to the 12. How about the y? That definitely changed. What do you think I put right here? 2y to the 0, 2y to the what? 1. Does that make sense to you? All I did is stick in a 2 right next to the y, and then I had to put it to the same powers as I was going to before. Now, simplify this down for me, please, though. Let's make sure you know what to do with that 2. Pause for a minute while you try that. Okay. So, I hope you got 13 choose 1 was 13. X to the 12th. 2, well, 2y to the 1 is just 2y. But if you leave it that way, I mark it wrong because you haven't simplified it all the way. So just put the 2 with the 13. It's not that hard. 26x to the 12th y. All right. Last thought on this. What if I had said, here's my problem, and I had said, without you doing anything, if I'd have said, which term has an x to the 12th in it, you could keep doing terms until you finally found one that had an x to the 12th in it? Yeah, it's that one that we just did, okay? See what I mean? All right. Okay, so let's see if you really got this. Here's a binomial. Let's see if you can expand it. 2x plus 3 to the 4th. Expand it all the way. I might be like, but there was always a y over there. It's just not, there's 3 there now. Pause for a second. Let me give that a shot. I want to let you know what your homework is, so hold on a sec. Okay, so here's what I assigned for that last. I assigned the bear page. Yep, have a good day. And I had to do problems 1 and 2 on the bear page, and then also this blue page after it has a great practice problem on it. That's all I need you to do for tomorrow as your homework. And that's all I have for the video for today.